performing analysis on data from an external source, while providing confidence that that data will only be used for contracted use, and doing this on an untrusted compute platform can be a huge challenge. Especially since input data can contain very sensitive information and the programs analyzing this kind of data may not adequately protect it from leakage. In some cases, the programs themselves need to be protected. SafeLiShare provides a great federated workflow mechanism to utilize confidential computing platforms to protect data and programs to come together from different domains and produce output under policy control. In this demo, we will show you a use case involving three actors: the hospital providing the input data, a provider providing a program with a model, and then the hospital receiving prediction output. First, the prediction program provider is going to encrypt his model and the program in what we call a Safelet, protected executable code, and publishes it to SafeLiShare platform. We refer to this as the first asset. Next, the hospital encrypts its data as an asset and publishes that asset. Both assets remain in the cloud account of their owners. They are registered in an asset catalog available on the SafeLiShare platform. Finally, the output receiver, hospital, creates an asset to hold the output, which is also registered. Any party then can examine the catalog and run the computation. Let's go ahead and create the three assets using the SafeLiShare client control command tool. To create the Safelet, we will specify the name of the safest and the location of the application Python code and the model. SafeLiShare creates the encrypted container and pushes it to the cloud registry. Separately, the hospital encrypts the input data to create datasets. The encrypted dataset is pushed to the hospital's cloud storage and published as the second asset. Hospital, as the third actor, provides an output attribute for specifying the output and publishes this to the cluster. The hospital also uses the SafeLiShare tool to create the dataset with a name and the location of the data input folder. The encrypted dataset is pushed to its own cloud storage. Once all three assets are created, they have to be published to the federation cluster. The hospital then runs a safe stream with these three published assets in the federation cluster. The policies associated with the assets are enforced by the SafeLiShare platform inside a confidential computing environment. Data and program decryption happens only inside the secure enclave. Programs run inside the secure enclave and process the decrypted data. All data encryption keys are provided to the secure enclave by the policy manager after validating the policies of all the owners. Output data is encrypted to the output owner's key before it leaves the enclave and produces immutable logs. Once the safe stream execution is completed, the output generated can be pulled and decrypted only by the hospital. In this demo, the privacy of the prediction program, model, and the privacy of hospital input data is protected by executing in confidential computing enclaves. SafeLiShare is fundamentally redefining today's data and application infrastructures to provide complete control over data residency, sovereignty, and compliance, and transparently encrypting all customer data in use, during execution, in transit, and at rest, so your workloads stay confidential and trusted. With SafeLiShare, customers always retain control so that they can embrace the cloud and innovate faster without the threat of code and data exposure. Seeking a better way to meet your customer data security requirements? We'd love to get in touch.